The force of attraction between two bodies at a certain separation is 10 newtons. What will be the force of attraction between them if the separation is reduced to half? There are two bodies which are separated by, let's say, distance d. Mass of the first body, let it be m1, and that of the second body be m2. The force of attraction between these two bodies having mass m1 and m2 and separated by distance d can be described by Newton's universal law of gravitation. F is equal to g multiplied by m1 multiplied by m2 divided by the distance between them square, d square. This force of attraction is already given. It is 10 newtons. F is equal to 10 newtons. Now the distance between them is reduced to half. Let us say the new distance is d dash. So m1 and this is m2. The distance has been reduced to half. So new distance is d dash. It will be equal to d divided by 2. F dash is what we need to find. So f dash will be equal to g multiplied by m1 multiplied by m2 divided by d dash square. Masses are not changing, just the distance is reduced to half. Now let me substitute d dash equal to d by 2. So f dash will be equal to g m1 m2 divided by d by 2 square. This will become d by 4. So 4 will come to the numerator. 4g m1 multiplied by m2 divided by d square. Now this term is f. So f dash is equal to 4f. So this is equal to 4 multiplied by f is 10 newtons. So f dash will be 40 newtons. So the force of attraction between the two bodies, if the separation is reduced to half, will be f dash equal to 40 newtons. Write the approximate weight of a body of mass 5 kilograms. What assumption have you made? So there is a body which is weighing 5 kilograms. We need to find its weight. Weight is calculated using the formula W is equal to mg. M is the mass and g is the acceleration due to gravity. If we take g as 9.8 meters per second square, we will get the value of W. W is equal to 5 multiplied by 9.8. So that would be 49 newtons. Sometimes the value of g is taken as 10 meters per second square. In that case, weight will be 5 multiplied by 10. So it would be 50 newtons. If the value of g is not given in the statement of the problem, you can take g as 9.8 meters per second square or 10 meters per second square. Calculate the weight of a body of mass 10 kilograms in kilogram force and Newton. Take g as 9.8 meters per second square. So there is a body having mass of 10 kilograms. Weight is the product of mass and acceleration due to gravity. G is 9.8 meters per second square and mass is 10 kilograms. Let us substitute these values. Weight will be equal to 10 kilograms multiplied by 9.8 meters per second square. W will be equal to 98 newtons. We have obtained weight in newtons. Now let us obtain weight in kilogram force, kgf. 1 kgf, kilogram force, is 9.8 newtons. So weight will be equal to 98 divided by 9.8. So that will give us 10 kgf, 10 kilogram force. So W is equal to 10 kgf. State the magnitude and direction of the force of gravity acting on a body of mass 5 kilograms. Take acceleration due to gravity g equal to 9.8 meters per second square. Now the magnitude of force of gravity F can be written as F equal to mg. Let us substitute the values. M is 5 kilograms, G is 9.8 meters per second square. So that would give me F equal to 49 newtons. Direction. Direction of the force of gravity will be vertically downwards. Towards the center of the earth. The weight of a body is 2 newtons. What is the mass of the body? Take G equal to 10 meters per second square. So here is a body having mass of, not mass, the weight, sorry, or just corrected, weight equal to 2 newtons. Now we are supposed to find the mass of the body. W can be written as the product of mass and acceleration due to gravity. Now let us write this equation in terms of mass. So M will be equal to W divided by G. Now W is 2 newtons and G is 10 meters per second square. So M will be equal to 2 newtons divided by 10. So this will give me the mass 0.2 kilograms. So mass of the body weighing 2 newtons is 0.2 2 kilograms. The weight of the body on Earth is 98 Newton, where the acceleration due to gravity is 9.8 meters per second square. What will be its mass and weight on the moon with the acceleration due to gravity 1.6 meters per second square? So on Earth, the body is having weight of 98 newtons. Okay, so on Earth it is weighing 98 newtons. Here the acceleration due to gravity is 9.8 meters per second square. Now the same body will be weighing differently on moon. Here the acceleration due to gravity is just 1.6 meters per second square. We need to find the weight. We also need to find the mass. Now first let us find the mass on Earth. W is equal to mg, product of mass and acceleration due to gravity. Let me write this in terms of mass. So mass will be W divided by g. Let me substitute the values. W is 98 newtons and g is 9.8 meters per second square on Earth. Therefore the mass will be 10 kgs. Now mass will remain the same whether the body is on Earth or moon. The mass of the body remains the same. Okay, so our first answer is m equal to 10 kilograms on moon also. Now let us find the weight on moon. Weight will definitely change because the value of g is less. Now weight on moon is equal to mg, but we will take g as 1.6 meters per second square. So mass is 10 kgs multiplied by 1.6 kg per 1.6 meters per second square. So that will give me 10 multiplied by 1.6 will be 16 newtons. So weight on moon is 16 newtons. A man weighs 600 Newton on Earth. What would be his approximate weight on moon? Give reason for your answer. The acceleration due to gravity on moon is 1/6 that of Earth. So the weight on moon will be 1/6 times the weight on Earth. Now let us substitute the value. W is given, it is 600 newtons. Let us substitute the value. W moon is equal to 1 divided by 6 multiplied by weight on Earth, that was 600 newtons. So weight on moon will be 100 newtons. The weight on the moon is less because the gravitational acceleration is lower on the moon compared to Earth. G of moon is 1/6 times the G on Earth. G is acceleration due to gravity. What is the force of gravity and weight of a block of mass 10.5 kilograms? Take G equal to 10 meters per second square. So there is a block. It is having mass of 10.5 kilograms. Now, force of gravity is weight. It is equal to product of mass and acceleration due to gravity. So F is equal to 10.5 kilograms multiplied by 10 meters per second square. Mass is 10.5, G is 10 meters per second square. So that would give me the force of gravity. It will be 105 newtons. It is same as the weight of the block. A ball is released from a height and it reaches the ground in 3 seconds. If G, acceleration due to gravity, is equal to 9.8 meters per second square, find the height from which the ball was released and the velocity with which the ball will strike the ground. So a ball is released from a certain height. Let's say it was released from a building. Okay. So ball has been released from this building. It is reaching the ground in 3 seconds. Acceleration due to gravity G is 9.8 meters per second square. We need to find this height. The height from which the ball was released. Now let us use the equation of motion. H is equal to half. In this case it would be gt square. H is equal to half multiplied by 9.8 meters per second square multiplied by 3 square. So H will be equal to 4.9 multiplied by 9. So H will be equal to 44.1 meters. The height of the building from which the ball was released is 44.1 meters. Now we are supposed to find the velocity with which the ball will strike the ground. So what is the velocity with which it will strike the ground? So let us use this equation. V equal to G multiplied by T. V is equal to 9.8 meters per second square multiplied by the time, which was 3 seconds. So this would give me the velocity with which the ball would strike the ground. That is equal to 29.4 meters per second. What force in Newton your muscles need to apply to hold a mass of 5 kilograms in your hand? State the assumption. There is an object which is having mass of 5 kilograms. Force required to hold this object will be F equal to mg, mass multiplied by acceleration due to gravity. M is 5 kg, and let us assume g to be equal to 9.8 meters per second square. F is equal to 5 multiplied by 9.8. Therefore, F will be 49 newtons. So 49 newton of force is required to hold a mass of 5 kilograms. And the assumption is g equal to 9.8 meters per second square.